Hi class, happy to see you again. In this lesson, I will talk about the formulation to know the basic MIP problems. Key of the lesson include to know the definition of OR problems and to know mathematical forms of OR problems. So what is the general linear programming form? We start from knows the definition of the linear programming. So linear programming is a class of the mathematical programming. Because of mathematical programming including other styles like nonlinear programming, Go programming, or dynamic programming and so on. Linear programming is a constraint optimization problem, which means in the problem there are a lot of different constraints. The purpose of the linear programming is to find a set of value for continuous variable x1 to xn that maximize or minimize a linear objective function, which satisfying a set of linear constraints. We write down in this form. Start from objective, then constraints. And all of the decision variable xi belongs to positive real number. Of course, included 0. And also, you can write down in minimization forms. It will like this: z equals to summation I ci xi, summation I a j I xi larger than bj for every j. xi belong to real number. You will find in standard form of maximization or minimization some difference in the form, like here, right? Maximize or minimize. And one of major differences here. In maximization problem, we use less or equal sign. In minimization problem, we use larger or equal sign. Why is that? You can think about that if we have a xi value for 4 or 3. For maximization problem, here we will have 3, a 4 ci larger than 3 ci, right? So you always can make xi as larger as possible to get a better performance indicator for the problem, so you cannot get the optimal solution. That's the reason why in standard form of the maximization we use less or equal sign. In minimization we use larger or equal sign for the problem. So you might get the feeling that the programming not really means the coding in computer, right? It means planning activity that consume resources and or meet requirements which express in the constraint. And also sometimes we will use the program replaced programming. Basically it's the same. Sometimes we will say linear program. Sometimes we will say linear programming. They are the same. And then now I want to introduce mixed integer linear programming, MIP. Sometimes we will also call it MILP. But MIP is more common. So mixed integer linear programming is a linear programming problem in which at least one of variable is restricted to integer values. So pure IP whose variables are restricted to be integer values. Here are the MIP form. There are some extra notation in objective and in constraint and for decision variable. Others are the same as the linear programming. Now, I want to introduce some very simple OR problem scenario. The first one is train scheduling. Because train is in our daily life, we can see it very common. So this kind of problem, we will analyze it. So for the scenarios of time scheduling is travel times between stations are known. Time spent in the station must lie in with a given interval. Two trains traveling on the same line must for variance be separated by at least a given number of minutes. To make a connection between trains A and B at a particular station, the difference between the arrival time of A and the departure time of B must sufficiently long to allow passengers to change, but sufficiently short so that the waiting time is not excessive. So our purpose is try to find a feasible schedule. Basically, the scheduling problem in IE domain, we'll call it NP-hard problem. You might don't know what is NP-hard problem. You can think that is a very difficult problem. Later on, I will explain what is NP-hard problem. And in this scenario, in order to find a feasible schedule, we need to know some parameters, right? Like traveling time and time span in a station and the distance or the time between two trains should be long enough for safety reason, and also the departure and arriving time for two trains connecting with each other must also have some distance between each other in order to that passengers have time to get on the train and not wait too long. Okay, so this kind of number, we call it parameter, which will influence the feasible schedule, right? And the second one is the airline crew scheduling. The scenario is the given flight for a particular aircraft type. One problem is to design weekly schedule for the crews. Each day, a crew must be assigned a duty period consisting of a set of one or more linking flights, satisfying numerous constraints such as limited total flying time, minimum rest between flights, and so on. The objective is to minimize the amount paid for crews. So, what is the problem belong to? Of course, it belongs to airline company. And the production planning is very common in IE field. Here is a scenario. A multinational company holds a monthly planning meeting in which a 3-month production and shipping plan is based on the latest estimate of the potential sales. The plan covers 200 to 400 products produced in 5 different factories with shipments to 50 sales areas. The goal is to maximize contribution. So we will know in this scenario, we need a lot of parameters, right? We need to get the data and put into our model and solve the problem. So it's a kind of complicated. If we have other very difficult constraint in our model, then it will become NP-hard problem as well. Okay. And a very interesting problem called dial ride for handicapped people. Okay, in several major cities, a service is available whereby handicapped subscribers can call in several hours beforehand with a request to be taken from A to B at a certain time, such as from home to hospital or hospital to home, with a special facility such as a space for a wheelchair if necessary. The short-term problem is to schedule a fleet of specialized minibus so as to satisfy a maximum number of requests. One long-term problem is to decide the optimal size of the fleet. So we have the same scenario. We can do the long-term problem or short-term problem, depends on your objective. Cutting problem. While cutting lengths of the paper from rolls, plastic from large rectangle sheets, or patterns to make clothes, the problem is in each case to follow precisely determined cutting rules, satisfy demand, and minimize waste. Of course, this kind of cutting problem also can be used in steel industry. Here is an example for paper industry. Very, very simple, because we only set up one machine to produce 3 different specs. Okay, so let's see the example. One machine can produce 82 centimeter wide paper. Some demand from customer. 58 centimeters wide paper, 5,000 meters. 26 centimeters wide paper, 8,500 meters. 23 centimeters wide paper, 9,000 meters. Assume that the paper can be cut in 58 centimeters, 26 centimeters, or 23 centimeters. Then the paper lengths can be combined together. Please determine a mathematical model and solve it in order to satisfy all the demands. That is minimizing the product length. Okay, so although this is a very simple problem, but the difficult point is how you set up decision variable, because it's kind of a combination of different lengths of the paper, right? Then you don't know how you cut the length of the paper, then combine together, right? So if you think about the decision, use the length of the paper, then you will get the trouble. Okay, so you can think about how you define the decision variables. Okay, maybe just 30 seconds. Okay, 20 seconds, 10 seconds, 5, 4, 3, 2, 1. Okay, so we can define the xi representing the length from the ice cutting method. So the decision method is we try to determine the kind of the cutting methods. Okay, in total there are 5 cutting methods to fulfill the specs of the customer demand. Okay, like this. if the paper roll is 82 centimeters, okay, then we can cut it by 58, 23, right? And we have a 1 centimeter wide waist. And we can cut like X2 method, right? We have the 26 times 3, and we have a 4 centimeters wide waist, okay? And we have the third cutting method. We cut it 23, 26, 26, and we have 7 centimeters waist, okay? And the fourth method to cut by 23, 23, 26, and the fifth cutting method is 23, 23, 23, and waist is 13 centimeters height. Okay, so we try to have these 5 cut methods, and we can put them together to meet the customer demands. And we want to let this part, right? This part. As small as possible, right? So in order to meet the demands, okay, so we need to know the length of the papers. So for total 58 centimeters, the total length is X1, right? Because we only have the way to cut 58, right? And for 26, so for 26, where is the spec comes from? It comes from the second, right? We have 3, X2, 2, X3, and 1, X4, right? Okay, so total length is 3 times X2 plus 2 times X3 plus X4. The same logic for the 23 centimeter spec. We have the X1 plus X3 plus 2X4 and 3X5. Okay, and we want to minimize what? Minimize the total length for the cut, right? So if you think about other decision variable, then this model will become very, very difficult. Okay, so now we can try to build this model, and you can do this by yourself first. And in next video, I'll try to do the GANs model for you, and you can compare your result and my result with each other to see if the result is correct. Okay, and if you have any problems related to the mathematical model for this example, or you don't know how to model in GANs, you can contact with me, and we can have some communication to know how you do the mathematical model, or how to solve the problem in GANs. Okay, so see you in next video. Bye.